PN4035, here's my week 9 submission video. So first off here I have an orthographic view of the project and also a pictorial view. It should be noted here that I have the frame set to transparent so you can see the components within the assembly, that the frame is actually made out of aluminium. So the basic motion of the project. Here I have a simple gear train, just the gears, there's no shafts or spaces or anything, just so you can see the basic motion. This initial gear is the drive gear, and then the gear train speeds up the input to this final gear where the motor will be attached to. Here on the right, I have a gear generator video, a more accurate 60 RPM input here to produce a 2880 RPM output, which is more than sufficient to produce 5 volts from a 12 volt DC motor. Here I have two exploded views of the two shafts and also an assembled view in the bottom left of this exploded view. So just to break down of the parts, I have a bearing housing, a washer, the bearing itself. The idea of the washer here is to isolate the inside of the bearing so there's not in friction with the frame. The shaft, take note of the hole here. This is where the spindle of the motor will be inserted directly into, and this is what will generate the electricity. So two spacers, two grub screws, and the gear itself. The idea of these obviously is to keep the gear in place, and then some bolts to attach the motor to the frame. So here I have another exploded view, this time of the first gear. Here is the crank and handle, just a nut and bolt here, some sheeting to make it more comfortable, a repurposed double ring offset spanner. The reason I've chosen an offset one is to create clearance here between this nut and what will be the frame so that they do not collide when the crank is in motion. So here I have a quick video of this assembled and in motion. So here I have an assembled view of the whole project. Unfortunately, my laptop kind of struggles running this. Sorry about that. So I'm hoping with the other 2 or 3 videos you can get an idea of how the electricity is generated from the crank the whole way down to the motor. Just briefly now, the materials involved are brass and aluminium. The brass for the shafts and the aluminium for the frames. The components, gears could be repurposed from a gearbox. The offset ring spanner, fairly obtainable. The size doesn't really matter. And then the bearings size relatively does not matter either because the brass can be turned down on the lathe to fit the bearings. And then the manufacturing processes, brazing to attach the brass to the aluminium, milling to produce the shafts, drilling to drill various holes in the aluminium frame, and turning then to fit the brass shafts into the bearings. So my operate environment, I've chosen rural Malawi. So my project doesn't really determine on any external forces like wind, rain, running water, or anything like that. The kinetic energy is produced by human power. So ideally, the project will be situated inside a building where any external forces or elements cannot mess up the project, because like wind and sand here could really affect the gears running. So we want to rule out that. And finally now, just mechanical lubricant such as WD-40 would be suitable to use on the gears to make sure everything runs smoothly. That brings me to the end of the presentation. Thank you.